Okay, so I'm going to go over solving a couple of exponential equations with you, and then I'll go over a couple log equations because you know she's going to ask those, right? So the first thing you should always try to do when you're solving an exponential equation is try to get the same base. She'll probably use a 2, a 3, a 4. I doubt she'll go any higher than that, maybe 5, but it'll probably be one of those bases would be my guess. So I'm going to do one here where we can get these to be both a base of 2. So we know that 4 is 2 squared, and then we still have the x in the exponent, and then we also know that 32 is 2 to the 5th, and then we have x minus 3 as the exponent. And now you just use the rule that when you have a power to a power, you multiply. So we're going to take these exponents and simplify them. So this one would be 2 to the 2x, and on this side we would get 2 to the, and then don't forget to distribute, 5x minus 3. And now since you have the same base on both sides, you can just drop the bases. So you get 2x equals 5x minus 3. If you subtract 5x from both sides, you get negative 3x equals negative 3. And if you divide both sides by negative 3, you get x equals 1. Okay? Now, the only thing that I'm a little bit worried that she might do is use a fractional base. I don't know if she's ever done that to you before, but I need you to realize that if you had a problem like this, so I won't change much except I'll make this 1/2, and we'll say to the, 3x equals, and we'll keep it pretty easy, we'll do 16 to the x plus 1. You can get a base of 2 out of both of these, and like I said, I'm not sure if you know this, but 1/2 is actually 2 to the negative 1. If you want to put that in your calculator just to make sure, but it's true because like if you have x to a negative 1, that's the same thing as 1 over x. So all I'm doing is going backwards. So if you have 1/2, that's the same thing as 2 to the negative 1. And the way you can remember that is 1/2 is 1 over 2 to the first. So if you want to bring the 2 up to get a base of 2, when you bring a base from the bottom, if it has a positive exponent, when you bring it to the top, it gets a negative exponent. Okay, so just in case she does that, this is what that would look like. Oh, sorry, I forgot the 3x here, so let me put the 3x there. And then this would be 2 to the 4th because that's 16 to the x plus 1. And then you do everything the same way, right? You multiply the exponents just like we did in the last problem. So you would get 2 to the negative 3x equals 2 to the 4x plus 1. And now you can drop the bases again. Negative 3x equals 4x plus 1, or negative 7x equals 1, or x equals negative 1/7. Okay, so that was just something I wanted to show you just in case she does it. That works all the time. So like another example in case she does this, if you have 1/4, right, and you want to get a base of 2, that would be the same thing as 1 over 2 squared. And since the 2 is in the bottom, that's the same thing as 2 to the negative 2. So like I said, you have a calculator, so you could mess around with it and just make sure it's the same. But I don't know that she'll do that. I guess you could check the first test she gave you to see if she did it on there. But just in case, you have that kind of in your back pocket. The only other type of exponential that I think she'll try is something like 3 to the x minus 1 equals, 7, right? And you're never going to get a same base there. So you can either take the log of both sides or the natural log of both sides. That's totally up to you. I just sort of stick with natural log. So if you say the natural log of 3 to the x minus 1 equals the natural log of 7, and now that you have the natural log of both sides, you're allowed to take this exponent and drop it in front. Okay, so you end up with x minus 1 times the natural log of 3 equals the natural log of 7. And we're trying to get to this x, and it's being multiplied by this number that's the natural log of 3. So you're going to divide by the natural log of 3. So you get x minus 1 equals the natural log of 7 over the natural log of 3, and then we just add 1 to both sides. So your final answer is this, and then you would just need to put it in a calculator. Okay? If you wanted to check it, all you would have to do is do 3 to whatever power this is, and it should get you 7. If you round this, though, it won't get you exactly 7 if you check it. Okay? Now, on the same kind of like type of problem, she could do something like this. She could do something like 3e to the 2x plus 5 equals, I don't know, 15. Actually, I don't want to have two of the same number in the problem, so we'll do 21. Okay. Now, again, this doesn't have to be divisible by 3, but I'm just trying to make it easy on you. So you want to isolate the base. Always isolate the base, and the base is e. Okay, so we're going to divide by 3 on both sides, and we would get e to the 2x plus 5 equals 7. And now to get that exponent to come down, just like we did over here, you take the natural log of both sides. So ln e to the 2x plus 5 equals ln 7. You can do this one of two ways. So there's a rule that she should have had you memorize that says the natural log of e to whatever the power is equal to that power. So you can just say that the natural log of e to the 2x plus 5 is 2x plus 5. If you can't remember that, then do this rule right here and drop that exponent down in front. So if you can't remember this rule, then, I mean, don't worry about it, but this is literally how it works. Like if you had ln e to the 5th, that's 5. If you have ln e to the smiley face, that's equal to smiley face. So whatever's up there, the natural log of e to that power is just the power. But like I said, if you can't remember that, then just drop this in front like we did over here. And I tell my students that's called the windshield wiper, because this is allowed to come down and it's allowed to go back up. So it sort of just goes back and forth. So like I said, if you can't remember that ln e to a power is just the power, then just go ahead and write it like this. Your calculator will do the work for you here. You're going to divide both sides by the natural log of e at this point. However, another natural log rule is that the natural log of e is just 1. So technically, we can just say this is 1 and we don't need it, okay? But again, if you forget that, your calculator will take care of it. So it's really not that big of a deal if you forget. So really, this is 2x plus 5 equals just the natural log of 7. And like I said, now you just isolate this x. So we'll subtract 5 from both sides. So that's the natural log of 7. And I would put that in parentheses because you can't do the natural log of 7 minus 5. So this isn't the natural log of 2. It's the natural log of 7, which is a decimal, and then that result minus 5. Okay, so that's why I put it in parentheses. And then we're going to divide both sides by 2. So this final answer is x equals the natural log of 7 minus 5 all over 2. Okay? That should take care of the different types of exponentials. Maybe like if you have something like this, like if she goes like completely bananas and is like, okay, 4 times 2 to the, I don't know, 5x plus 7 minus 9 equals 11. Like, let's just say she just throws everything at you. You still want to isolate the base. Always isolate the base. So that means you undo everything that's being done to this base. So in this case, we would add 9 to both sides. So we would get 4 times the base to the power. So we're just kind of working through everything here. Then we still want to isolate the base. So we would divide by 4. And 20 divided by 4, that worked out nicely. That's 5. And now you have to get the exponent down. So take the log or the natural log of both sides. Okay, now since this isn't base e, this side isn't 5x plus 7. You actually have to like do the work on that. The other mistake that you're going to make is you're going to forget to take the natural log of both sides. Like I almost did there, I almost just left that as a 5. So be really careful. Okay, now you're allowed to windshield wipe, so you're allowed to bring this down. So 5x plus 7 times the natural log of 2 equals the natural log of 5. And again, that's just like every problem I've just done with you. Divide by the natural log of 2 because we're trying to isolate the variable. That's all you do in algebra is isolate variables, get them by themselves. Okay, and then subtract 7 and divide by 5. So I'll just kind of do it all at once. So the natural log of 5 over the natural log of 2, then minus 7, you got to do it in the correct order, and then we would divide by 5. And so this is your final answer, and you could just type that in a calculator. Okay, so those are exponentials. Make sure maybe watch this another time. Click subscribe, click like, send it to all your friends. Just kidding. I make no money off of this. But no, seriously, like I would definitely watch that a couple of times. Go back and do the problems on your test that you missed. I'd be happy to send you more problems, like whatever you want. Okay. All right. So I'm going to show you a couple of log equations that she might ask. Okay. Now, there really are only two things she could do. She could do log base x. So b is any number, as long as it's greater than 0 and not 1. But don't worry about that. She's not going to do that to you. Equals log base b of y. So if you get a problem in this sort of like setup, all you have to do is drop the logs and say x equals y and be done. Now, you might have to actually do some work, right? Like, because she might put more expressions in there, but you can just drop the logs. So if you get single log equals single log, drop the logs. Okay, so here's a really quick example. If you get log base b of 7x equals, oh, I made it base 5, whatever, it doesn't matter, equals log base 5 of 21, all you do is drop the logs, and you get 7x equals 21, or x equals 3, and you're done. That's it. Okay, so that's the easiest, log equals log. Now, a little play off of that is if you had something like log base whatever of, I don't know, 4x plus log base 3 of 2 equals log base 3 of, I don't know, I'm just trying to make some stuff up here, x minus 1. Okay, this is not log equals log, right? It's not a single log equals a single log. So you have to condense, okay? So you got to remember, if you have multiple logs, the first thing you have to do is condense, okay? So to condense two logs that are being added, you write it as one log with the expressions being multiplied together. So this is log base 3 of 4x times 2. So now we've condensed the log, and on the right-hand side we have a log. So here we are with log equals log, so we can drop the logs. So we would say 2 times 4x is 8x equals x minus 1. And then I would subtract this x over, and I would get 7x equals negative 1, or x equals negative 1/7. Okay? Now, one thing I didn't bring up in the first problem is, with logs, you have to remember that when you take the log of something, so I'll just do this, x has to be greater than 0, okay? You cannot take the log of 0 and you can't take the log of a negative. That does not mean you only have to check negative answers, which kind of sucks. So when you solve your problem, plug it back in and make sure it's not making you take the log of 0 or a negative. Since 7 times 3 is 21, you're fine there. But this answer right here is a problem, okay? So when you plug this back in to either here or here, it doesn't really matter. If it makes one of them undefined, you're done. So if I plug negative 1/7 in for x, it's going to make me take the log of negative 4/7, and I cannot take the log of a negative, okay? So actually, there's no solution to this problem. And I don't know if she's ever done that to you. You could get two answers and one of them doesn't work. You could get two answers and neither of them work. You could get two answers and they both work, okay? Don't assume that just because something is negative, it doesn't work. You plug it back in, and if it makes you take the log of 0 or a negative, it doesn't work, okay? So that's how you would do log equals log and drop the logs. The only other type of problem is if you get something in this setup. So if you get log base b of x equals y. So just a log, okay? You can never just drop the log. This is where you have to exponentiate, okay? So to exponentiate, you do base to the other side, which is this y in my problem, is equal to whatever you're taking the log of. So it's b to the y equals x, okay? And if the log is on the left-hand side and the number or whatever is on the right, this is always going to make a greater than sign, okay? So if you look, b to the y equals x. b to the y equals x, okay? So I'll show you a setup of that problem. So you could have something like log base 2 of 3x plus 1 equals 4, okay? You're never going to get that to be log equals log. The right-hand side doesn't have a logarithm, right? So you just exponentiate, and you say, okay, 2 to the 4th, so 2 to the 4th equals 3x plus 1. And then just simplify. So 2 to the 4th is 16 equals 3x plus 1. Subtract 1 from both sides. 15 equals 3x. Divide both sides by 3, and you get x equals 5. And then real quickly, plug it in. 3 times 5 is 15, plus 1 is 16, so that's a positive number. It's not 0, so this is fine. Okay? Now, to piggyback off that, she could also do this. This is like that multiple log situation that I did earlier where you have to condense. And then, though, you can't drop the logs because there's no log on the right-hand side. You'll have to exponentiate. So again, you have multiple logs, so let's go ahead and condense. So it's going to be log base 2, and since these are being added, you're going to multiply. So x times x minus 3 equals 2. There's no log on the right-hand side. So I condense the logs. Hold on. Callie stole Dixie's bone, so now she's upset. Here, do. Over there. Okay. You can write this as log base 2 of x squared minus 3x. So all I did was distribute the x and then equals 2. So listen, you're never going to get log equals log, right? So now we have to exponentiate. All right, so here we go. 2 to the second equals x squared minus 3x. So 2 to the second equals x squared minus 3x. So that's 4 equals x squared minus 3x. It's a quadratic, so set it equal to 0, and we'll factor. So this will be 4 and 1. It'll be minus 4 plus 1 equals 0. So we get x equals 4, and we get x equals negative 1. If we plug 4 in, you can take the log of 4, so that's fine. If we plug 4 in here, you get log base 2 of 1. That's also fine. So the 4 is good. If we plug the negative 1 in, you'll see we're in trouble already, right? Because that'd be log base 2 of negative 1. You can't take the log of a negative. So the only answer to this problem is 4. Okay? Just also remember, if she does something like this, like log base 3 of x minus log base 3 of 7 equals, I don't know, 2, right? So now you have subtraction. So when you go to condense this, it would be log base 3 of x over 7 equals 2. and then you would exponentiate. So 3 squared equals x over 7. So 3 squared equals x over 7. So 3 squared is 9 equals x over 7. Multiply 7 to both sides, you get 63 equals x. If you check it, that's not making you take the log of a negative number, so that answer would work. Okay. Maybe one other thing I could see her doing would be something like putting a number in front of a log, like this. Like maybe like that. If that happened, you would divide both sides by 2, like that, and you would get log base 3 of x equals 6. And then, again, you don't have a log on the right, so you would exponentiate. So 3 to the 6th equals x. Okay? Maybe you could see her doing something like this. The natural log of x, and let's see, I'll put a number in front of this. How about we'll do 3 ln x equals, I don't know, 15. So you would divide by 3 first. You would get the natural log of x equals 5. And to exponentiate this, you have to remember that the natural log of x is really log base e of x. You just don't write that because it doesn't look cute. So this is really this, right? So you would get e to the 5th equals x. Okay, so I could see her doing that. And then maybe, if she wants to be a little bit sneaky, the log of x equals 4. And then you have to remember there's an assumed 10 there, right? So it would be 10 to the 4th. Oops. 10 to the 4th equals x. Okay? I would make sure that you know what an exponential and log graph look like. Okay, we definitely went over that because she might ask you to graph those. So, just make sure you know what a log and an exponential graph look like. Make sure you know how to move your graphs up, down, left, right. Okay, because I'm sure she'll ask you those types of things. But yeah, like I said, if you need anything else, just let me know, and good luck on your test.